Then I would like to invite Jacco, Elias, and Sebastian to start presenting the project, and later on we will explain more about Manufacturing NextMaterials.
Yep, it's my turn to present. I hope you now see my screen. So I will take up the presentation if nasty questions appear on really the in-depth CFDs. Simulations, and Elias or Sebastian will step in. But yeah, we indeed work together with Femto Engineering on the design or innovation of our 3D metal printed catalytic reactor structures. So that's what we do, so we're situated in the south of the Netherlands. And Femto is situated in Münster, in the border region of North Rhine-Westphalia, and we work together, and they perform the CFD analysis. Some background of us first. I'm Jacco Hoekstra, CTO of AddCat, and AddCat stands for Additive Manufacturing and Catalysis, and we design and manufacture these catalytic reactors using 3D metal printing. This enables a high design freedom, and that's with normal fabrication procedures you cannot produce. And the application that we're active in is either in air purification, either in the industry, but also building in oxidation catalysts in oven equipment to remove smelly compounds. Prerequisite that you need for a catalytic reaction to occur is the contact of a catalyst surface with the volatile organic compounds or the smelly compounds. And the other one is that you need the correct temperature. On the right-hand side, on the bottom, you see a catalyst particle that is integrated on the complex reactor structure just above it. And well, the graphical image displays there that with the use of catalyst, the temperature of a reaction goes down. With this optimized internal geometry, we try to optimize the heat and mass transfer. So make sure that the complete catalyst system is the optimal temperature for the catalytic conversion to occur, and also to optimize the mass transfer. And with that, we mean that that we want to make sure that all the contaminants come into contact with the catalyst surface, and in that sense have a controlled flow distribution of what we aim for. And this should result in compact, efficient, and high-performance reactors. Femto is specialist in computer-aided engineering, and they use advanced computer simulation to predict how products or structures will perform, and they can do this even before they are being built, just behind the computer. Expertise lies in structural and thermomechanical modeling, including dynamic and nonlinear behavior, and they also make sure that their customers are compliant with industry standards. So core expertise is flow simulation using computational fluid dynamics, looking into heat transfer, but also multi-phase flows or coupled multi-physics, which means that they see how the interaction between flow, heat transfer, structural characteristics interact with each other. And a few examples are indicated on the right-hand side, what they work on. Bottom one is, for example, the temperature distribution of a combustion chamber of a jet engine. So the objectives that we wanted to achieve within this project is to first minimize pressure drop, is the amount of resistance of your reactor structure, of course, because this costs a lot of energy, and on the other hand, maximum conversion efficiency, and these are always parameters that are intertwined. So with this, we want to develop more predictive performance, because of course we always spend a lot of time in the lab doing these experiments, which is time consuming and can become expensive. But hopefully with these efforts, we have a more predictive performance. And with the CFD-driven design optimization, we would like to see if we can tailor the reactor configurations to some specific line requirements. Of course, you want to have a baseline product, what you sell, but customers usually need some adaptation to their systems. Finally, I'll show you an example how we evaluated and optimized this for the integration of such reactor structure in some existing production equipment. All in all, in that we would like to achieve an accelerated development cycle. So the approach that we took is twofold. For our side, we performed the design of experiments on various 3D printed metal structures and measured the key performance indicators. So the main ones are pressure drop and conversion efficiency and how these interact with each other. The design parameters that we investigated and the structures that we printed, you see on the right, are the interior wall thickness, the channel dimensions, how wide these channels are, and the amount of complexity being built in these reactor structures. Basically, Femto did the same experiments, but then behind the computer. So we were in the lab, but they did exactly the same with our models to look into also the pressure drop, flow distribution, and all in all, the reactor performance. And if all is well, this matches, but of course all was not well. And we started to perform some pressure drop measurements, first of all on the test benches indicated over here. Of course, we did this with a printed structure as depicted on the bottom right. Top right is the CAD model. You see already quite some differences in there. I'll explain this a bit further on the next slide, but well, I delivered some data. Sebastian and some of his colleagues performed some CFD analysis, and we get some random results, but the plots did not align. So we needed to sit down together and say, hey, what's going on? First of all, we looked at our setup. It could use some improvements. So that's what we did. And also in the CFD analysis, some adjustments were made. And finally, in the third slide, we were able to have a really good predictive performance. And I'll show you on the next slide what went wrong initially. So top right, you see a zoom in of the CAD model, very straight lines, and on the bottom is the same design, but then actually printed and zoomed in with a scanning electron microscope. You see that the edges are much more rounded. You have some rough surfaces here and there inherent due to 3D metal printing. And this proved to be the key to align data from the lab with data behind the computer. So the model in the computer was adapted with much more rounded edges, as you can see from the top and the bottom over here. Here is pretty square, here is much more rounded. You immediately see in the velocity flow distribution that makes a big difference, and this is directly related to pressure drop, but also conversion. But now we could mimic much more reliably behind the computer what was going on in real life. And that's just to the difference in between printing and CAD design. So finally, we managed to get rid of these discrepancies and have now a very nice model to be able to predict what's going on and make much more easier iterations. Next up, we looked into the conversion. Here's this very small reactor setup in which we stacked a number of these disks, provided them with a catalyst, and let air flow through with a certain amount of benchmark contaminant, in this case toluene, and then we stepwise increase the temperature, and on the y-axis you see the increase in conversion going from 0 to roughly almost 100% in this reactor setup. And from this data, we could extract some relevant parameters that Femto needed for their CFD models, like activation energies. And with that, we could take the next step to see how the conversions were going. So here you see some very nice graphical images. On the left-hand side, reactor structures, single channels through the reactor, basically, because if you want to model a complete structure, it becomes more complex for the computer and it starts to smoke itself. But from the left hand is a much narrower channel than on the right-hand side. And well, this means that the molecules need to travel a much less distance to the catalyst surface, reach it much faster. So this gives a better conversion, and also with an increase in complexity. This also helps. So then you say, okay, more complexity, thinner channels, that's the way to go. But of course, then the pressure drop penalty comes into play, which you see on those images over here. On the left-hand side and the right-hand side, you see a lot of difference in the air velocity distribution. On the right-hand side is much more evenly distributed, hence a much lower pressure drop. So with this data set on hand, and on one hand the pressure drop, and the other hand the conversion data, you can really find and tweak the optimum for every customer. Usually have some sort of boundary conditions regarding maximum pressure they can overcome in their systems. And or requirements on they really need to have this in this performance. This varies usually, and then with this data in hand, we can really say, okay, this customer needs this and this data. So this is our predicted performance. So let's now go to the lab and it goes much quicker than that you need to do all these experiments consecutively. So we looked into the fundamentals of an oven system of one of the customers that we were speaking to, and this is the system depicted the situation as was. So the block on the top and the bottom, the yellow colored ones, in which you see the velocity distribution. This is where the catalysts are placed, but you see two design flaws. One is that a lot of air actually can bypass the catalyst, so that the space is not completely filled, so that air is not being treated. And also you see some backflow in the, for example, the top catalyst, so not all the air is traveling into the right direction. So in that oven system, the customer was a bit aware, okay, this is not an optimal system, but when we showed them these images, it's okay, there's quite a lot of things to be gained, and this convinced them to take the next step with us and into the further development. So this really shows that it was a big help. We in principle, we knew the benefits of our system ourselves pretty well, but it's much more convincing if you can have these images, talk to the customer and say, hey, this is the problem you right now have, and this is what we can improve. For each customer, we can optimize this to take into account this conversion versus pressure drop factor. So to conclude, we in this only a small project, but we gained a very much deeper fundamental insight into our own catalytic reactor technology with a data-driven understanding of all the properties that are relevant: flow, conversion, heat transfer, and this really helped to accelerate the design automation per customer. And as I said, this is much less cumbersome if I need to do all these experiments in the lab. What Sebastian and Femto did behind the computer, I would have been finished in 2030, and now we're in half a year further, and we can show, hey, of course we're not there yet, but we have a clear route forwards. Yeah, we have a bit of background, did some CFD analysis ourselves sometimes with some, if we were lucky enough to have a student that had some capabilities in that sense. But well, their experiences in that sense is very worthwhile and valuable to us. It really had a strong increase in customer interest and a clearer value and proposition towards our customers. And I think the support of the Interreg program was pretty important for that. The outlook, so we were lucky enough to have a follow-up project also granted. So the basics were there. We showed some benefits in an oven structure of one of our customers, potential customers, I would say, but this really convinced them to take the next step with us. And lucky enough, we are now able to, with a follow-up project within the Interreg project, to really do some dedicated CFD analysis in this oven, together with emission measurements done by ourselves in a customer supplied oven. And the customer is now actually involved in experimental design and setup. And with this result in hand, we are also able to attract some other larger customers in the same field. So why Interreg? It helps, I think, to reduce innovation risks. We tested and validated new technologies with some nice funding and a lower financial burden, which is also for a startup, of course, always looking for funding. Really, the excellent complementary experience and expertise, I would really recommend to look for companies that have expertise that you don't have in-house, of course. That really helped us a lot to create also new business opportunities. Of course, building a lasting relationship, I think, with Femto, looking already into some other projects together. And yeah, from Interreg's side, I think it's a very nice, so smaller but really dedicated projects you can do. So if you have something like we did with one specific customer, this is really a large industrial player. So for us, it's a really big fish. If you can do something like this, it helps tremendously in getting credibility. So for the funding application is not that difficult, straightforward application procedure. I'm sure Hilde and other people will come back to this. In the meantime, if things are not 100% of the first application, or they say, okay, maybe you want to improve this. This helps a lot. So in that sense, we have now successfully applied for 2 proposals, and one is granted. There's only luckily a limited amount of administrative work involved, so that helps a lot. With that, I would like to thank you for your attention, and I'll give the word back to Hilde. Thank you.
Thank you very much. We will quickly give another presentation about the Interreg Manufacturing NextMaterials itself, and after that we combine all the questions. So I will start sharing my screen as well, because we have the amazing Manufacturing NextMaterials program, of which the project from AddCat and Femto was one. And it is really focusing on supporting SMEs with flexible manufacturing technologies, but also technologies to test the outcome that are needed to transform smart and sustainable materials into, for example, lightweight components, advanced battery systems, renewable energy solutions, but like the project, also other markets. We support SMEs in consortia across the border, so Dutch and German companies, help them with design setups for pilot production lines and test procedures, and we transfer knowledge via workshops and this webinar. Within the project, we have the open part, of which this project is a part, but we also have 3 lighthouse projects. The first one is Next Thermoplastic Composite Productions from Kato Composites and TPAC in Enschede, that develop an energy-efficient pilot production line for sustainable composites. Then we have Advanced Solutions for Battery Materials, in which the Fraunhofer Innovation Platform in Enschede works together with the University of Münster and Fraunhofer FFB in Münster. And then we have Distributed Additive Manufacturing, for which the University of Duisburg-Essen is really in the lead. These are examples. You can also contact these lighthouses for information. They also have space for test productions. So you can really contact them, and we can provide the contact details if necessary. So please let us know if that's the case. Who can submit a project? Dutch and German companies within the Interreg program area. In the Netherlands, that is Overijssel, all the provinces except from the western provinces of Noord- and Zuid-Holland, Zeeland, and the west of North-Brabant. And in Germany is parts of Niedersachsen and parts of North Rhine-Westphalia. Where do we focus on? We focus on sustainable and advanced materials. That is really broad. Also, the materials on the screen are an example. But we work with smart materials, for example, combined with electronics, sensors, data, high-tech metals and coatings, modern textiles, composite materials, materials for energy generation, distribution and storage, optics, ceramics, and so on. So if you have an advanced material, you can apply for a project. And what can you then receive? We have up to 70,000 euros per project. So that has to be divided between the 2 partners. And that's then 50% of the costs of the project. Only personnel costs are eligible for grant. That is, we count that with a fixed rate, and on top of that 40% overhead to cover other costs, but that also makes sure that the administrative burden is not that high. You have to write the hours, and then half of the hours are paid, of course, with the calculation with the 40% overhead. And the projects can take up to 10 months if you apply in the next deadline, because all work must be completed in August 2027. Well, how does this process look like? It looks long, but it's actually quite manageable. We do a first review at OSNL. We are the lead partner of this project, and we can do the first review of your rough project idea. And if it fits, you can write the full application. That also prevents you writing a full application that does not fit. And once you have filled in a full application, we can also review it and improve it before it is sent to the Bijraad or the expert committee. This committee reviews the projects and gives an advice. We always receive that advice first, so we can also give you the feedback. Then there's also time to adjust and improve the project if the Bijraad sees opportunity to do this. All projects go ideally with a positive advice to the steering committee of Interreg. We have a really high success rate at the moment. So if I'm correct, it's 95%. We have open calls with a deadline, and the next deadline is on September 4, just after the summer holidays. And the lead time from the deadline to actual approval is approximately 12 days. So we have a deadline this time in September. On September 4, the open call is already open earlier, 1 month before. So if you want to have your project reviewed by us, you can send it to us before. Then the deadline is on September 4. The Bijraad consensus meeting will be later in the same month. And then the end of October, the steering committee of Interreg will make the decision. And if the project is approved, you can start on the 1st of November. So how can you benefit from this project as a company, but also as a knowledge institution? You can apply for a scale-up project or an innovation project, just like the project just presented by AddCat and Femto. This really minimizes your risks, unlocks more potential for the material, and can scale up your production. Workshops and trainings, just like this webinar, and matchmaking. So you can expand your network within both the Netherlands and Germany, but you can also make use of our network to find a Dutch-German cooperation partner. And we are financed by the provinces in the Netherlands and the ministries in Germany. That was this part. So if you are really interested in doing a project within M&M or want to receive the grants, you can always contact us. I will stop sharing the screen because we have now time for questions. I also see some comments in the chat already. Yeah. The info email to contact us has been shared in the chat environment. Yeah. This opens the floor for questions to both AddCat and Femto or about the project itself.
Maybe I have a question, Hilde. So we are now, it's not an SME, but how does it work? Can you also work together with companies that are outside of SME status?
It is possible. It does, however, form a big risk because the Interreg program is not really keen on giving those companies grants. So theoretically, it is possible to work with bigger companies that are no longer SMEs, but they can only receive a small portion of the grant if Interreg allows them to receive it.
Okay.
And if I may add to that, if you want to do that, you also have to give quite a good explanation why this specific company is valuable and why you can only do it with this company.
Okay, thanks. Yeah, clear.
Seems like the presentations were quite clear. Maybe another question then is, does it spark interest among the guests in this webinar? Someone who wants to say something about that?
Jacco, I can imagine that if people are hesitant to ask specific questions here about your presentation, that they can also reach out to you outside of this session.
Yeah. I'll put my email in the chat.
Perfect. And then I see a hand raised by Hendrik Kuster.
Yes, thank you very much. I'm not sure if I missed this information, but have you an estimation about the success rate if a company or a consortium applies in M&M?
Yeah, it's up to 95%. We have had approximately 12 projects to the steering committee so far, and only one has been rejected.
So that's quite high. Okay, so
yeah,
looks like a big chance. Okay, thank you.
Yeah,
and that's also due to the process, as Hilde has already presented, that we really also give initial feedback to the proposal that you would make to improve it. And also the Bijraad sometimes gives feedback to further improve the proposal. So by the time it is at the Interreg Steering Committee, you have had several opportunities to process feedback and improve it.
And the access to the networks of the partners, if you're in search of a partner, right?
Yes.
Thank you. Yes, maybe to clarify, in Germany we have NMWP that you can contact, but you can also contact Emsland GmbH or one of the other partners like the University of Duisburg-Essen, Inos GmbH. All points of contacts if you want to check your project idea or have questions about the project. And in the Netherlands, you can, for example, ask us at OostNL for the provinces of Gelderland and Overijssel, but also, for example, Brabant. But we also have the Brabantse Ontwikkelingsmaatschappij and, for example, the Northern Development Agency, TCNN, as a partner. We have Saxion, we have Kato Composite, so there are quite some companies that you can contact. But yeah, if you have you want to apply for a project, it is best to ask us directly at OostNL. But if you're still in need of a partner, you can also contact the other partners, either via us or directly. If there are no more, oh, Dirk, yeah.
Sorry, you said already something about the way to participate or to find a partner. So that means that I don't have to have a partner at the beginning, is it always to have an idea?
You can have an idea without a project partner on the other side of the board, yes. And we can support you then in finding the right partner for your project idea, yes.
And could you say something about the amount of work for preparatory or
it really depends. Yeah, you mean for the project application? Yeah, if you have found a partner, we mostly see that the initiating partner writes the proposal first. We provide a format for that with a maximum amount of characters to prevent it being really extensive. It also shouldn't be too much into detail of the technique. It can be a bit high over as long as it is clear that it's innovative and new for the companies and really can make an impact. And then mostly the other partner reviews and adds bits and pieces to it about their role in the project. And then mostly that is also the time that the partners contact us. So that we can review it and we can fine tune it until a good proposal that can go towards the Bijraad. So the work is not really that extensive. So it could probably be done. For example, if you find a partner next week, it's still feasible to apply for the next deadline. Or if you find it, it's in September. So if there are not too much trouble with the summer holidays, you can even find a partner later.
Thank you. Sounds good.
And Jacco, you have also lived through this process in the meantime twice.
Yeah.
So how was your experience in coming to a proposal and handing it in and get a positive decision?
Well, it's what I said already during the presentations. It's really straightforward, and Hilde explains indeed there's a clear template, what kind of information. Of course, the project should be new, innovative, and I think indeed also to show the business side of the potential, what you can reach. Of course, I think that is very important. But yeah, I've written EU Horizon proposals. You have months and months of work. This one, a few days of putting your teeth together, and you're halfway there. And then together with your partner, and also input from example, for OCNL, that helps to say, okay, this is the pain point still. If you address those, the chance of getting granted are better. So yeah, pretty straightforward.